In this class, we will solve some more problems based on Coulomb's law. Let us read this. The sum of two charges is 7 microcoulomb. They repel each other with a force of 1 Newton when kept 30 centimeter apart in free space. One Newton when kept 30 centimeter apart in free space. Calculate the value of each charge. So we don't need a full stop here. Actually, it should be a comma. This is Newton. 1 Newton. The sum of two charges is 7 microcoulomb. They repel each other with a force of 1 Newton when kept 30 centimeter apart in free space. Calculate the value of each charge. Here the force value is given and the sum of two charges are also given. Now we need to calculate what are those charges. Can you try this? Let us assume the first charge as x microcoulomb. So let us say we have two charges Q1 and Q2. We don't know the value of Q1 and Q2. We need to find out. And the separation is 30 centimeter is given. Let the charge Q1 equal to x microcoulomb. We don't know. So let us take it as x microcoulomb. Given Q1 plus Q2 is 7 microcoulomb. Therefore, Q2 can be written as 7 minus Q1. Microcoulomb. We have taken Q1 as x, so Q2 is 7 minus x microcoulomb. Now the force is also given. We know by Coulomb's law. You can write here by Coulomb's law. We have F is 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Substitute all the values. Given F is 1 Newton and we know 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into Q1 we took x microcoulomb. Q2 is 7 in minus x microcoulomb. Micro is 10 to the power 6. So this 10 to the power 6 comes from micro. Divided by R square. R is given as 30 centimeter. Go back to the problem and see R is 30 centimeter. Convert centimeter to meters. So we will get 30 into 10 to the power minus 2. It is 0.3 square. Or 30 into 10 to the power minus 2 square. Now we have to simplify this. So 30 into 10 to the power minus 2 can be written as 0.3 also. So this will become 1 equal to 9 into 10 to the power 9 into x into 7 minus x. So I'll take 10 to the power minus 6, 10 to the power minus 6, that is 10 to the power minus 12, divided by 30 into 10 to the power minus 2 is nothing but 0.3 square. Now equate 0.3 square is can also be written as 9 into 10 to the power minus 2. 3 square is 9, so it is 0.09, which is nothing but 9 into 10 to the power minus 2, equal to 9 into 10 to the power, we have 9 minus 12 into x into 7 minus x. Simplify. Here 9 minus 12, that is minus 3, and 10 to the power minus 2. So they cancel, and here 10 to the power minus 1 will remain. You can bring that 10 to the power minus 1 to the other side. So we will get 10 equal to x into 7 minus x. So this is equal to 7x minus x square. It is a quadratic equation. X square minus 7x plus 10 equal to 0. This will give you x minus 2. Solve this quadratic equation. You will get x is equal to 2 or x is equal to 5. From this we get x is equal to 2 microcoulomb and 5 microcoulomb. X is equal to 2, sorry, not x is equal to 2 microcoulomb. X is equal to 2 and x is equal to 5. So if x is equal to 2, then Q1 is 2 microcoulomb and Q2 is 5 microcoulomb. If you take x is equal to 5, you will get Q1 is 5 and Q2 is 2. The two charges are 2 microcoulomb and 5 microcoulomb. You can write finally two charges are 2 microcoulomb and 5 microcoulomb. Next we will take another problem. Plot a graph showing the variation of Coulomb's force F versus 1 by r square, where r is the distance between two charges, 1 microcoulomb, 2 microcoulomb and 1 microcoulomb minus 3 microcoulomb. Interpret the graphs obtained. What is asking? Plot the graph of F versus 1 by r square. This problem is to plot the graph of F versus 1 by r square. And two pairs of charges are given. One is 1 microcoulomb, 2 microcoulomb, another one is 1 microcoulomb minus 3 microcoulomb. So we have a combination of one charge here, 1 microcoulomb, distance of both is r, 2 microcoulomb. The second pair is 1 microcoulomb, same distance, minus 3 microcoulomb. Here coulomb is also there, 1 microcoulomb in the question, no? Just note down, this is minus 3 microcoulomb. We need to plot F versus 1 by r square for these two pair of charges. Now we need to know how the value of F varies for these two pairs of charges. So by Coulomb's law, the force is given by, the magnitude of the force is 1 by 4 pi epsilon naught into Q1 Q2 divided by r square. Now for a given pair of Q1 Q2, F will vary inversely as 1 by r square. 1 by 4 pi epsilon naught anyway it is a constant. For given Q1 Q2, because here Q1 Q2 is given, that is why I am taking for given Q1 Q2, F is proportional to 1 by r square. Because for given F, so this, for given Q1 Q2, this will become constant and F will vary depending upon the distance. F is inversely proportional to 1 by r square. Now if you plot a graph, the slope of this will depend on Q1 Q2. F is, so this is proportional, F is proportional to 1 by r square. When you plot the graph, you will get a straight line. Therefore the slope of F versus 1 by r square graph depends on Q1 Q2. The slope depends on Q1 Q2. Now you consider the given pair of charge. First one is 1 microcoulomb, 2 microcoulomb, and the second pair is 1 microcoulomb minus 3 microcoulomb. If you see, for the second pair, the magnitude of Q1 Q2 is higher because it is 1 multiplied by 3. So the 3 here, 2 into 1, it is 2. So given pair, here the slope is higher for the second pair of charges. Q1 Q2 magnitude is higher for the second pair, that is 1 microcoulomb minus 3 microcoulomb. So if you plot a graph, the slope is higher for the second pair. So this is for second pair and this graph will be for first. Force versus 1 by r square. So this is for 1 microcoulomb minus 3 microcoulomb, and lesser slope is for 1 microcoulomb, 2 microcoulomb. The question says interpret the graphs obtained. We can write higher the magnitude of product of charges, higher the slope. Higher the magnitude of the product of charges Q1, Q2, higher the slope. Higher the magnitude of product of charges Q1, Q2, higher is the slope.